Now we're going to look at vectors, vector review from pre-calculus. So remember that a vector is made up of a directed line segment with an arrow at the end to denote direction. So a vector is a directed line segment or array, and the arrow indicates direction. Okay, we write a vector as v, or the name of the vector with that little mark on top, or you use a bold V for a vector. Okay, we write the magnitude of the vector is basically the length of the vector. Okay, so the magnitude is made up of, the way we write that is with the double absolute value signs, and it is equal to the x length squared plus the y length squared, and then that value square rooted, or the vector of x squared plus the vector of y squared, and then the whole value square rooted. Basically the distance formula. All right, so we get our x and y portions of the vector by just making a right triangle. So the x portion is the horizontal length of the vector, and the vertical length of the vector is, or the rise of the vector is, the y length. So we write that in component form as x comma y with the pointy brackets. Direction is just the angle that the vector is pointed in. So we use inverse tangent to figure out the angle. So we use the inverse tangent of the y length over the x length, but we do have to be careful to consider what quadrant you're in, because when we use inverse tangent, your calculator will only give you the answer in quadrants 1 or quadrants 4. So if you're in quadrant 3 or if your vector is facing quadrant 3 or facing quadrant 2, you have to add pi to your answer. Okay, an equivalent vector is the same magnitude and direction, but the vector may be have a different initial point. So right now my vector is in standard form. So my initial point starts at the origin 0, 0, and moves in an x comma y direction. An equivalent vector would have the same magnitude and direction, but maybe your initial point starts somewhere else. Okay. All right. So we're going to start with the initial point of a vector is -1, 3, and the terminal point is 2, 7, and we're going to graph the vector first. So I have -1, 3, -1, 1, 2, 3, and should have used a larger grid. Okay, the terminal point is 1, 2, 1, 2, 3, 4, 5, 6, 7. A little off there. Okay, so this right here is my vector, and I'm going to graph the same vector in standard form. So with this vector, I know that in the x direction, I'm moving 1, 1, 2, 3 units, and up 1, 2, 3, 4 units. So my x is equal to 3 and my y is equal to 4. So if I start at 0, 0, I need to move over 1, 2, 3, and up 1, 2, 3, 4 units, and my vectors will be equivalent. Okay, so we're going to go ahead and give the component form of the vector. So we kind of already, if we know the change in x and we know the change in y of the vector, then we can write our vector in component form. So our vector in component form would be 3, 4, since it moves 3 units right and then 4 units up to get to the terminal point. The magnitude of the vector, we're going to go ahead and is the magnitude of, we're going to call this vector v, is equal to the square root of x squared plus y squared. So I end up with the square root of 3 squared plus 4 squared, which I know is equal to 5. All right, part E, find the direction of the vector. For some reason, this one always trips you all up. The direction is just the angle of the vector. So we start with the tangent inverse of y over x. So I get the tangent inverse of 4 over 3, which is in radians is equal to, or is about equal to, 0.927 radians. All right, up next, find the direction of the vector that given by -3, 5. So if I just give myself a quick sketch of what that looks like, that is -3 and up. So I'm going to start with my vector in standard form just because that seems like the easiest place to start, but you can draw it wherever you want. Okay, so I'm going to count -3 and up 5. So my vector is pointing into the third quadrant. Just kidding, the second quadrant. Okay, so I'm going to start with theta is equal to the inverse tan of 5 over -3. And I went ahead and typed that into my calculator, and I got just about equal to -1.030. Okay. Okay, remember this angle right here is facing into the fourth quadrant. So to get the value of our angle in the second quadrant, we need to add pi. So to get my angle, I'm just going to say that the angle here is equal to beta. Okay, so beta is equal to theta plus pi, so which is equal to -1. So this is angle theta is equal to -1.030 plus pi. So in my oh, you couldn't see any of that. Okay, so here we go. The angle -1.03 is in quadrant 4. So, but my ray faces quadrant 2. So I need to add pi to get my angle into quadrant 2. So I'm going to make my angle right here. I'm just going to label it as beta. So beta is equal to theta plus pi. So I'm going to start with my quadrant 4 angle of -1.030 and add pi to it. So here, going back to my calculator, oops, I'm going to add pi, which gives me 2.111. Okay, so the angle beta is equal to 2.111 radians. That's this guy. All right. So the magnitude of the vector v is equal to 6, and the direction is theta is equal to 2 pi over 3. So I need to write this vector in component form. So one thing that we need to remember is that the angle tells me where the vector is. So 2 pi over 3 is in the second quadrant. So my angle is equal to 2 pi over 3. The length of the vector is equal to the magnitude, which is 6. So basically, if I'm looking for the vector in component form, I want to know what's the x and the y, the change in x and the change in y to construct my vector. All right. So the way I'm going to do that is that x in trig is equal to the radius times the cosine of theta, and y is equal to the radius times the sine of theta. So I know that my component form of my vector is going to equal r times the cosine of theta, comma, r times the sine of theta. Okay, so I know what r is. It's the length of the vector, which we can call the magnitude, times the cosine of 2 pi over 3, and then the magnitude of v times the sine of 2 pi over 3. Okay, let's sub in some 6 times the cosine of 2 pi over 3, comma 6 times the sine of 2 pi over 3. You can probably skip a lot of these steps. Okay, so cosine of 2 pi over 3 is equal to 1/2. So you have 6 times 1/2, because this angle here is 60 degrees. So the shorter side would be the x side, the taller side would be the y side. So I'm going to multiply 6 times the sine of 2 pi over 3, or times root 3 over 2. Okay, and I just simplify to give me 3 comma 3 root 3. Okay, that's vectors for now.